and then the reed switch closes. There's another 470 ohm resistor in the anemometer to prevent it from burning in case this is shorted to plus 12 volts. You have 1 micro electrical capacitor that discharges into the transistor after this goes off, after it's off, giving it a pulse, and we see that on LED 2. Diode 1 rectifies, it's probably not necessary, but just prevents current from backflowing from the capacitor to the LED, get discharged. The capacitor and diode adjustable twin pot are for charge discharge, basically the pulse width and also the threshold of triggering Q2, which is a 23904 regular NPN transistor. So if you turn on the transistor when you get a past the threshold, we supply power to a Joule thief circuit here. Okay, and that's the little red LED that you see down here that's blinking. So every time you get a pulse, the Joule thief oscillates at about 40 kilohertz and sends a pulse through LED 3 and also lighting it slightly to 600 k ohm resistor to ground and driving the gate of the MOSFET Q3 and the IRF 46N. Okay, and the power to these two is supplied through a normal closed relay switch, which is normally on and until we turn it off. We'll cover that in a bit. So the source of the FET MOSFET is powering another LED here, LED 4, just to give us indication of the pulses. And also connected directly to the motor, permanent DC motor, permanent magnet DC motor generator. Okay. Purpose of this is to pulse the motor to reduce the startup voltage, startup wind speed. So basically kickstart the windmill into turning, and then maintaining that by the wind, and start to generate power. Okay, so now when we come over here, we see there's a diode that's one diode off of a bridge, 25 amp bridge, and goes to the system plus 12 volts, which is hooked up to the MPPT battery controller, and also the right there, and also grid tie inverter. It's hooked up to power to the house. Okay, so right now it's generating, but not generating enough to make any useful. So until it is, we have a boost voltage, which is right now just a 5-volt supply. Okay, just a computer type switching power supply that's being added to the circuit here. So it's going across this diode. So we have minus plus 5 through close contact of the relay through D3, and so basically bypassing this and adding 5 volts. So the battery controller and the grid inverter, we started operating at about 10.5 volts. So that helps to start turning on both the charger and the charge controller and inverter, and start charging and producing power. Okay, so then what we have is when the generator is producing enough power on its own, that means it's over 10.5 volts, and that's sensed by this Zener diode, which in this case is PNP 2N4122 transistor reverse bias base emitter, and another junction added to it through a resistor, a capacitor to for hysteresis, into a Q5, which is another 2N3904, which turns on the relay and indicates that by LED 5. When it turns on the relay, this opens up, so it's no longer pulsing into the generator, and it's no longer adding 5 volts in series with the generator. So then it's full power from generator to through diode rectifier into the system, 12 volts. Okay, this 12 volts is 12 volts battery, and that controls the system, the controller. Okay, so that's about it. Right now we don't have that much wind to do anything useful, so right now it's not even turning. So I forgot to mention, and I need to draw that in here, there is a bulb in series which can be bypassed, so to further reduce current and voltage to the generator. In the future I will be looking at changing this circuit here to fully turn this on, because it is quite warm. It's not so warm now with the bulb, but with that bypass, with the jumper in there, it was getting pretty warm because it was constantly driving the motor with pulses at not full turn on. But now see, you don't have any pulses coming in at all, so the wind is dead. So anyway, I'll explain it again some more when we actually have enough wind where we can monitor the start and finish turning on the relay, and which is when the relay is turned on, it's basically normal operation without KickStart or Boost. Okay, Talk to you later. As you can see, the anemometer is dead. It's not turning at all. So, you know how much wind now to show anything. Wind is just picking up now, but it's coming from northeast, northwest, so the horn is blocking it. Well, we're getting some there. So, coming from northwest, still blocked by the horn. If you get either north or west, you might get rotation. If you overcome the threshold, then you should actually start turning. But I mean, the wind speed is like very light, 10 kilometers an hour right now. As you can see, that one started turning, but barely. So there's not much, not enough to start. So the whole thing of the circuit is trying to increase the efficiency of this whole system and make it more usable. More of the time. Otherwise, it would only turn on at about 25 kilometers an hour wind, and all the other wind from about 15 to 25 would be wasted. So this way we get at least a little bit. So that's the aim. Alright, thank you. Talk to you soon.